All right, guys, so the last case we want to look at is when an equation could have what's called infinite solutions. Okay, so we're going to solve this out like normal. Again, we're just going to distribute first, put all my secret ones there, and start the process. So 6 distributes in. Remember, distribute just means multiply. So 6 times -1 is -6x. 6 times 3 is positive 18. And then we have a -4 I can bring down. We have a -2x to bring down. And then we can start distributing this 2 or multiplying it into the parentheses. 2 times -2 is -4x. And then 2 times 7 is positive 14. Okay. So we've distributed because we have parentheses. Now we want to combine our like terms. So I'm going to look at the left-hand side of the equation. I have a 6x, and then 2 constants, an 18, and a -4. We know that the 6x does not combine with constants because it's a variable, but these two, 18 and -4, will combine. I have 18, and -4 is just -4, so 14. We now have, on the right-hand side, we got to try to combine like terms. So I have -2x, a -4x, and then a positive 14. So this time our variables can combine with some stuff. So -2 and -4 combine. -2, -4 is just -4. Is a -6x. So we're going to put those together. We have -6x. And we have this positive 14 comes down. Now we have variables on both sides. So right away, what I'm going to do is try to pick on the little guy. But again, something funny happens, right? The variables on both sides are exactly the same. So when you try to pick on one, let's say I try to add 6x to both sides. What happens is they don't just cancel off on one side, they cancel off on both sides. And we're not left with the variable anymore. We're left with the statement 14 is equal to 14. Right? And so we say, wow, this is kind of confusing. But I know that 14 equals 14 is true, right? That's a true statement. And even furthermore, the step before that, we had this -6x plus 14 is equal to -6x plus 14. Those are the same expressions on both sides of the equation. So whenever this happens, what we're going to say is we're going to say that this equation here has infinite solutions. Or you can say x is all real numbers, basically. That's the same thing. Infinitely many solutions, that's the same thing. The idea is basically the left-hand side and the right-hand side of this equation are really the same expressions. They're just written differently. So when we do all our simplifying, we're left with the same thing, right? And so since it's the same thing on a graph, that would look like I graphed one line, and then the other line would be directly on top of it. They're basically the same line. And so they touch everywhere, right? And that's all it means for an equation to have infinite solutions.